everyone. This is Mrs. Myers with a lesson on two-step equations. I'm here with my second period class. Say hello.
Hello.
So we've been looking at models for solving two-step equations, and today we're going to use pencil paper and we're going to fill in our foldable. So the first example that we have here is 3x plus 2 equals 23. So the first thing that we want to do when we're solving equations is to go ahead and put a line down the middle so that we can look at the two different sides. Our goal when solving an equation is to isolate our variable. So in this case, our variable is x. We're trying to get x by itself. So when we're solving equations, we're actually undoing what's been done to the x value. We actually know that 3x plus 2 is equal to 23. So when we were evaluating expressions earlier, we would do things like plug in a value for x and then solve it, following the order of operations until we got the answer. With equations, we're going to do the opposite. We're going to undo what's been done to x so that we can figure out what x is. So we're actually going to follow the order of operations backwards. So you could write this on your notes. We're going to go backwards in our order of operations. So what that means is we're going to undo addition and subtraction. Oops. We're going to undo our addition subtraction before we undo our multiplication and division, before we undo our exponents, and before we undo our grouping. So grouping would actually be solved last because we are undoing something. Whereas when we were evaluating expressions or we were evaluating the formulas, surface area and volume, you plug something in and you get the answer. But now we already have the answer and we're trying to figure out what the x value is. So we're working backwards. So if you notice here, next to our variable, we have a 3x plus 2. The first thing that we're going to do is undo our addition. So we undo addition by subtracting. So this is a positive 2. We're adding 2, and we get rid of that by subtracting 2. Or with our models, we'd be putting in a negative 2. So you're going to subtract 2 from both sides. When I subtract 2 from the left side, what do I get? What's 2 minus 2? 0. So it cancels out, but we still have 3x. So we're going to bring down our 3x. And then on the right side, we subtracted 2 or added a negative 2. And we're going to have 21. Now we're still not done because we want to isolate our variable, and we have not. We have a 3 in front of the x, which means we have 3 x's. If I want to go from 3 x's to 1, I'm going to undo my multiplication. And the way I undo my multiplication is division. So I'm going to divide both sides by 3. And x is going to be equal to 7. So again, we followed the steps. We looked at our order of operations, and we solved it in reverse to get to our solution to our equation. So the next thing we would do is we would check it. So to check our equation, we're going to put the 7 in to our original equation. So I'm going to do that right here. So I'm going to put in 3. I'm going to put in 7 for x plus 2 equals 23. And if I evaluate that, 3 times 7 is 21. I'm adding my 2, and I'm going to see if this is indeed 23. 21 plus 2 is 23. 23 is equal to 23, so this is going to check. And this is really important that we do that part, we do the check, so that we can eliminate any errors we may have had in our solutions. All right, let's take a look at our second example on our foldable. Our second example, we have negative 2y minus 7 equals 3. Just like in the last one, I'm going to draw a line. I'm going to highlight my variable because that's what I'm trying to isolate. I'm trying to isolate y or get y by itself. Going backwards with my order of operations, addition and subtraction, I'm going to follow first or solve for first. Multiplication, division, exponents, and grouping is going to come last. So if you notice on this side, I have 2 times y, which is multiplication, but I have minus 7. So I'm going to start with undoing my subtraction. I undo subtraction by adding. So I'm going to add 7 to both sides of my equation because I'm undoing it. Negative 7 plus 7 is going to cancel out. On the right side, 3 plus 7 is going to give us 10. So I have 10 on the right side, and on the left, I'm going to bring down what I still have, which is negative 2y. Now this one's a little bit different because our coefficient or our number next to the y is what type of number? It's a negative number. So this time we have a negative. Now remember, we're going to undo our multiplication. So we have multiplication. So we're to this step. So how do I undo multiplication? By dividing. So I'm going to divide. So I'm going to divide by the same number that the y was multiplied by. What was y multiplied by? Negative 2. So you're actually going to divide by negative 2. We didn't see dividing by a negative in our models, but we need to understand what we need to do. Whatever you multiply something by, that's what you're going to divide by. If it's a negative, it has to be a negative. So then your negative 2 divided by negative 2 cancels out. That's a 1 because negative 2 divided by negative 2 is 1. We're going to bring down our y. And then 10 divided by negative 2 is what? Negative 5. Good. All right, for our check, over here, we're going to do our check. We're going to simply put in our number, negative 2. What did we get for y? Negative 5. We're just plugging it in, and we're going to see if it's equal to 3.
All right, good morning.
All right, so to check it, I have negative 2 times negative 5. You guys can use calculators when you're doing these. Don't try to do them in your head necessarily. And you can do your checks. And 3 equals 3, so it's going to be a check. All right, we've got 2 more equations to try, one that has multiplication and one that has division. This will be the first time we look at a division equation. So let's go ahead to the next equation. So now we have negative 3n minus 8 equals 7. We're going to put our line down the center. We're trying to isolate our n value. So I have negative 8 or minus 8. So I get rid of that by adding 8 to both sides. This is going to cancel out. I'm going to bring down my negative 3n. 7 plus 8 is what? 15. Okay, so again, I have multiplication with my variable. How do I undo multiplication? By dividing, and I'm going to divide by the same number it was multiplied by. This is a negative 3, so that means I have to divide by a negative 3. And then n is going to be equal to 15 divided by negative 3, which is negative 5. Then over on the right side, we're going to go ahead and do our check. So our check is just putting in what we got for n and seeing if it's right. So negative 3 times negative 5 minus 8. And we want to make sure that that's equal to 7 because that's what the equation has. If I multiply negative 3 times negative 5, I get 15. And then I bring down my minus 8. And 15 minus 8 is 7. And that's 7. So look what you've done. When you've evaluated the expression, you get down to what the answer is. And then that is what our value is for n. So you see we're working backwards to the answer, whereas when we're evaluating expressions, we're working the other direction. All right, we're going to go over our last example. This one's a little different because it involves division. So let's take a look at that last example. So this time we have k divided by -2 plus 7 is equal to 10. So again, we are trying to isolate our variable. This time our variable is up here at the top with k. And just like the other problems, we're going to go ahead and put our line down the middle. So we're going to put our line down the middle. And we're going to solve for our variable k. We're trying to get it by itself. So remember, if we had modeled this, we would have a +7 counters. And in order to get rid of the +7 counters, we're going to take away 7 or add -7 to both sides of the equation. And when you do that, our +7 cancels out. And on the right side, we have 10 minus 7, which is 3. We still have this piece here to deal with. Some of you, I notice when you're solving your equations, you're stopping with the first step. But remember, these are two-step equations, so you've got to continue to the next step. So we're going to bring k divided by -2 down. And just to be helpful, what would be helpful is to go ahead and highlight each time you have your variable so that you can remember that you're trying to get that by itself. So this time we have division. And so to undo division, so this bar here means division, means to divide. And we're trying to undo that. And we undo addition, we do the opposite operation. So to undo division, we're going to multiply by -2. So we're going to multiply both sides here by a -2. When we multiply the left side by a -2, and again, it has to be the -2 because that's the number that we've divided by. To undo what we've divided by, we have to multiply by the exact same number, just the inverse operation. So this here is going to cancel out. And it cancels out because -2 divided by -2 is just 1, and that's what we want. We just want 1k. So we bring down our k. Because now we've isolated, we have just 1k. It's not necessary to put the 1 in front of it. It is just 1k. And then on the other side, we have 3 times -2, which gives us a -6. The other important part of this is that we need to be checking. So our check, we're going to put our number back in. So I'm going to put in, for k, I got -6. I'm going to put that into my original equation, -6 divided by -2 plus 7, and I want to know if that's equal to 10. Okay, now one of the things we can do it step by step and evaluate the expression on the left side, but the other things we can be doing is using our Desmos calculator. So let's take a look at the Desmos calculator to do that. So I'm going to pull that up. And then if you look at our equation, I can simply put -6 divided by -2 plus 7 into my equation. So it's going to be -6 divided by -2. Oops, let's clear that. I'm going to try that again. I'm going to start with my fraction bar. -6 on the bottom, -2. I'm going to click outside my division. I'm going to add 7. And let's see what I get. You notice that we get the same thing. We're looking for that 10, and we have that 10 right here. So we can see that this actually checks. So by using our Desmos, we can use our calculator, and we get 10 is equal to 10. So this is a check. Okay, that's an example of a few of the types of two-step equations that we'll be solving, and you should have these listed in your Foldable.